Welcome to Ethereum Pet Shop tutorial. In this tutorial, we'll be building our first app, which is called distributed application. We'll be creating an adoption tracking system for a pet shop. So let's dive into the demo. The first step of the demo is to install Node Package Manager, Node.js software, and Git. I already have this in my machine. We'll not be checking how to install this. It's quite simple. We just need to go into these links, download the executable, and install it like a usual software. And the next step is to install Truffle framework via npm package. So let me open command line so that we can install Truffle. Before installing Truffle, let me check my Node Package Manager version just to make sure that we have Node Package Manager. So we have the version of 3.10.10. Let me check the Git version as well. So Git version is 2.14.3. So we have both and we are good to go. The next thing is to install Truffle. We'll install with command npm install -g truffle. The flag -g indicates we are installing it globally. This will take a little time. So we now can see the npm truffle command got completed. It installed Truffle. So the next step is to create a directory. We have to create a directory. It's called Pet Shop Tutorial. I'll be doing all the demos in a directory under my C drive, and I called it as deep dive. So this is the command to create Pet Shop Tutorial folder. Okay, it already exists. Let me create, let me remove the Pet Shop Tutorial directory itself and recreate it. So it removed it. So now I'll create the directory again with mkdir command, and then we will move into that directory. So the next step is to download the project. Truffle has something called Truffle box. So we can create our own projects, and if we want anyone else to download it, they can download it. So for this demo, Truffle has already created a box called Pet Shop. So we'll be using this command to unbox it, which means that it will download the Pet Shop folder and all the required files to run this demo. So let me paste the same command. So now we can see the download is completed. It unpacked, it did setup, and it gives a message unbox successful and sweet. So these are the commands which we'll be using. We can compile, migrate, test, and run our web interface to connect to blockchain. So the next step is to check the directory structure. If you see what Truffle has unboxed, we can see folders called contracts, migrations, test, truffle.js. We'll see what these folders are, what will be inside. The names itself are quite self-explanatory. Contracts folder will have all the smart contracts. Migrations folder will have all the migrations. When we say migrations, all the smart contracts that are there in the contracts folder will be migrating into the blockchain, and will keep track of what is migrated and will not migrate whatever has already migrated. And we have a folder called test where we have all our test scripts, and will make sure that before deploying into a public Ethereum blockchain, we'll make sure we do all the tests and we are good to go. And Truffle.js is a configuration file where we can configure to which blockchain environment or to which node we'll be deploying our smart contract. So let's check the directory structure in command line. I'll just give dir, and you can see contracts, migrations, test, truffle.js. There are other folders and files as well, which we need to run the demo. It has node modules. It has all the node modules that are required to run web interface, and src will have all the web files that we need to run this demo. So let's open all these files in an editor. I'll be using Visual Studio Code for this. If we give code dot, it will open up the folder in Visual Studio Code. So we can see the folder structure here, contracts, migrations, truffle.js. Let's go to the next step. And the next step is writing the smart contract itself for our adoption tracking system for Pet Shop. So we'll create a new file called adoption.sol in contracts directory. Let's right click the contracts directory and click on new file and give the name adoption.sol. The next step is to write the smart contract itself. We just have a couple of statements here. Let's copy these two statements and paste it in the file. So the first line indicates that we need at least Solidity compiler, which is 0.4.4 at least, and the caret symbol in front of it says either 0.4.4 or anything above than that. So this particular line will be understood by compiler while compiling the code. And the next line is just we are just creating a smart contract and we called it as adoption. The next step is setting up the variables. Solidity is a statistically typed language, which means that we need to declare all the variables before we use it. Solidity has a unique type called address, and here we are creating addresses array which whose size is 16, and we call this array as public and we name it as adopters. So address is a special type as we have discussed. So every Ethereum account will have an address, and every smart contract in Ethereum will also have an address. An address is a place where we store value, and in this particular demo we'll be tracking which pet has is adopted by which Ethereum address. So our pet store has only place for 16 pets. So that's the reason we'll have only 16 addresses, and these 16 addresses will assign whomever want to adopt. Their addresses will be added here. And the name public indicates, and the keyword, it's a keyword. The public indicates that when we deploy the smart contract, we'll get an address back, and whoever has this address, they can see all these addresses and their information. The name public itself says that anyone can read it. Anyone can read it provided they have the contract address. Now the next step is to write a function. So we call this function as adopt, and it takes a parameter called pet id, which is an unsigned integer, and it returns an unsigned integer, and this method is public. So anyone who has the smart contract address, they can trigger this. So the require command says it's something like a continue kind of command. When it is if there is not exactly continue. So if the condition is satisfied, then only it will execute the next two steps. And the condition is the pet id should be greater than or equal to 0 and pet id should be less than or equal to 15. As we have only 16 pets in our pet shop, we make sure that the user is not passing anything other than the numbers between 0 and 15, as the array index starts from 0. So after this, if this condition is met, we'll go to the next line, and adopters is nothing but addresses. This is the public variable that we have declared. It's an array of addresses of 16. So now what we are trying to say is, so whichever is the number passed, so for that number in the array, we are assigning something called msg.sender. So msg.sender is a special way of retrieving whoever has triggered this function. Their address will be stored here. It means that if someone wants to voluntarily adopt a pet shop, and if they have the smart contract address, they'll trigger this function. When they trigger this function, this particular variable msg.sender will have the Ethereum address of their account, and that will be added to the adopters of pet ID, which virtually indicates that they are adopting this pet. And if this is successful, we'll return a pet ID. So let's copy this function and paste it in our just beside the beneath the public variable, and let's save it. So let's go to the next step. The next step is creating a function to get all the addresses back. It's quite straightforward. It doesn't take anything and it returns all the addresses of the pets, like pet adopters. So we have 16 addresses, so we are returning all those 16 addresses here. So let me copy this and paste it beneath the adopt function. So let's go to the next step, compiling and migrating the smart contract. So for this, we have something called Truffle Developer Console. So the developer console is something which creates a developer blockchain into which we can deploy our smart contracts and test. So in order to get into the developer console, we give a command called truffle develop. So let's go into my directory and say truffle develop. So it opens up the development console for me. So if you see, it has created a development blockchain at this RPC address, HTTP localhost 9545, and it has created about 10 accounts. And by default, yeah, all these 10 accounts will have 100 Ether in their wallet. And the next step is to compile the smart contracts. And the command to compile the smart contract is just compile. So what does it do is it will take the two smart contracts that are there under the contracts folder, and create it will compile and it creates the abstract interface definition for the smart contracts. So the command is compile to compile the smart contracts. So we are still in developer console and we type in compile and compiling the smart contracts. And if you see here, we don't have any build folder, but the build folder will be generated now, and we can see the compile. So we can see that all the artifacts are written to build contracts. So as you see, a new directory called build is created, and we have the JSON format of contracts, adoption.json and migrations.json. So now the Solidity has taken the smart contract and converted it into the bytecode, the language which Ethereum virtual machine can understand. Now that we have compiled our smart contracts, the next step is to migrate the smart contracts to the blockchain. So right now we have two smart contracts. One is migrations.sol contract and adoption.sol contract. So in order to migrate migrations.sol contract, we already have a migration file called initial migration. So this is the one which takes care of deploying it to the blockchain. So we need to create a some similar file for our adoption.sol also to migrate or deploy to our blockchain. So for that, we'll be creating a new file and we call it as to underscore deploy underscore contracts.js. So the initial number 2 just indicates that which smart contract we are deploying and how we are going to deploy. So always migrations need to be the first smart contract which will be deployed. It is used to track how many contracts are deployed so far. And we'll just copy this. This is the migration code. So if you see that we need an artifact called adoption, which means that it brings up this adoption.json file, and it uses the export function to deploy it. So it by default gets an object called deployer, and With deployer, we have a method called deploy, and we'll be deploying whatever we have compiled into that Truffle blockchain. So it basically deploys our two smart contracts into the blockchain, the Truffle developer console, with the blockchain that's created by Truffle developer console, and we can access this with RPC, with this RPC protocol HTTP localhost 9545. Now that we have both migration files, we'll just type in migrate in developer console. So let's type in migrate. So we can see that deploying migrations, and this is the address where it deployed. So I think this is something like address of the migrations.js. Sorry, this is the address of it. And for our adoption.sol, this is the address of the smart contract. So we have seen the same output that we have got here, but the addresses are different. Now the next step is to test the smart contract that we have deployed. So for this, we'll create a file called test.adoption.sol, and all the tests will go under the folder test. So let me create a file under test, and we call it as test.adoption.sol. We'll be writing all these commands in our test.adoption.sol. So now note that we have started off with three import statements. So we are importing assert.solidity file, deployed address.solidity file. These are all inbuilt, which comes from Truffle framework. So these are useful when we are trying to test the smart contract that we have written. And the third one is we are importing the adoption.solidity contract that we have already deployed. Now let's write our test methods. So the first test method that we are going to write is test user can adopt pet. So in this we'll be testing our adopt method in smart contract. So we are calling adoption dot adopt, and we are passing an ID of 8, which means that whoever is triggering this contract now, they will be assigned to this pet. So the pet whose number is 8 will be assigned to whoever is triggering this contract. And remember the function that we have written in adoption.sol, the adopt function, it gives back the ID. So if you see this, so we can expect an ID 8 to come back. So we'll use the assert dot equal function. The return ID and expected ID should be same. And this is a message which we want to display if the assert is true. So let's copy this test method and paste it in the test adoption.sol. So we didn't talk about the adoption variable here. So if you see in the contract itself, we have defined this variable, and how we get this, we'll be getting the instance of the deployed contract by using this deployed address dot adoption of method, by using the default solidity file provided by Truffle. Now let's write test method for the other function. So the second function that we are going to test is test get adopter addresses by pet ID. I'm copying the and we'll be pasting it here, under the first test method. So now we are testing the adopters method address by pet ID. So what we are trying to do is, so whoever has triggered the smart contract, we are getting their address into the expected variable, and we get eighth address of the adopters, and they both should be same. So which means that the owner of eighth pet ID should be the one whoever has triggered this. The third test method is to check all the addresses that are getting retrieved. So this is, I've copied the test method and I'm pasting it here. So in the function name itself is self-explanatory. It says that test get adopter address by pet ID in array. So we are getting the address whoever has triggered the smart contract, and we are getting all the adopters. So if you remember, this get adopters is a method which will return all the adapters in the smart contract. So when we get it back, the eighth one should be the current account whichever has triggered this. So right now we have three test methods and we should be good to go to test all these three methods. So now how do we test it? So we can remove this memory, which means that when we return this, when we get all the addresses back, we are storing it in memory. With latest Truffle, we can't use the memory option. So I'll be removing the memory keyword here. It doesn't make much difference. It means that we are creating a storage and we are storing all the addresses here. Now let's run the test. So it's very simple to run the test. We'll just type in test. It says it's using the network develop. Compilation failed. So it says variable is declared as a storage provider. Use an explicit storage keyword. I think I might be wrong. I need to go back and have the memory keyword. So let's run it again. I think this time it's running fine. If everything is if everything is good, all the three test cases should be completed as successful. So it's okay. All the three tests have passed now. So we are good to go. So we have already seen the screen. All the tests are good. Now creating a user interface to interact with the smart contract. So we have already seen that in src folder, when we unboxed, we already got a folder called src and it has all the CSS fonts, images, and the index.html. So we'll be using this web interface to talk to the Truffle developed blockchain. So the first step is to copy this code and paste it in app.js. So let's go to the code editor. We have JS and app.js file, and it says replace in this init web3 function. So this code has a special meaning. So web3 is the interface with which we talk to blockchain. It's a web interface. We can use web3 with JavaScript. So there are few browser extensions with which we can get web3 instance. So we need to create a Web3 instance, and a Web3 instance is something which can talk to your blockchain. In order to create it, we need to have the URL with which we talk to blockchain. So if we have few browser versions, Web3 will be automatically injected. And that's the reason we are checking. If it is not undefined, we'll take the current provider, whichever the browser extension gives us. So we'll talk about MetaMask, which is a browser extension. So we can paste the URL, talk to your blockchain, and it will automatically inject Web3. And if we don't have anything like that, we will be creating a Web3 instance, which will be connected via this. And if you see the develop console, the Truffle develop console. So initially when we created, it's created at HTTP localhost 9545. So maybe we just need to change this, but anyway, we'll be using MetaMask to inject this and finally create the Web3 instance and return the or call the init contract method. So the init contract method is here, and we again need to replace the code that's provided in the tutorial itself. Let's let's go to that code. So init contract is nothing but initiating the contract, and this is how we do it. $.get.json adoption.json. We have already seen this adoption.json, so it's under the build folder which got created when we compiled it. So it takes in this adoption.json and then installs it in the Truffle developer console blockchain. So it's straightforward. We got the JSON file as the data, and we took that articraft and we created the Truffle contract, and we assigned it to app.contracts.adoption, and then we, we did set the provider, and now we call another method called mark adopted. Mark adopted is the next method. So what we are trying to do is, like, it has all the required, this JSON file has all the required information to talk to the blockchain, and we do it with the truffle contract function, which gives back the adoption contract, and with this we'll talk to the smart contract. The next thing to do is the mark adopted method. So let's go to the tutorial back, and we have the code here. So what this does is it will call the adoption whenever this is called. It gets in the instance of this adoption contract, and it calls the get adopters method, and when the adopters are returned, we'll see we'll loop through all the adopters, and if for a particular pet, if there is an adopter assigned, this is the default for an address, so we mark the button as success and we disable it, or else we will have the button text as adopt. This is a simple um, jQuery code to tweak the button how it disappears. So in our web interface, we will see all the dogs, all the pets, and then whenever if anything is adopted, there will be no option to click the adopt button. If if a pet is not adopted, we'll provide a button, and if anyone are interested to adopt it, they can just click on adopt. That's how it works. So let me copy this code and go to the Visual Code Editor, Visual Studio Editor, and replace this. So it's all good enough. Everything is done, and there is only one thing left in the handle adopt. Let's go back to the tutorial and see. So this is the handling the adopt option, adopt function. So let's replace this code. We'll talk about this code now. Just replacing it and I save. So this is the handler which gets called whenever we click a button. So every button has an ID which gives us back what's the pet ID. And once we get the pet ID, we get all the accounts from web3.eth.get accounts. And then we'll take in the first account and we call the adoption smart contract that got deployed. And once we get the smart contract instance back, we call the adopt function with the pet ID and then from the first account. And if this is successful, we call the return mark adopted, which is something like which marks in web interface like this pet is already adopted. And if this fails, we'll just display an error message. So now that we have our web interface ready, so we need a browser extension called MetaMask to talk to our Truffle blockchain. So let's install the MetaMask browser extension. It's very easy to install. We can go to Google and say MetaMask extension. So the first one comes up. If you click on it, so it has this is the MetaMask extension. We can just add it to Chrome. Just say add extension. It will be adding the extension. So it has successfully installed, and I can see the icon here, the MetaMask icon. So that's how easy it is to install the extension. Once we installed, we just need to create a password. Before creating password, we just need to accept the license agreement. We just need to read through all the license agreements and then say accept. And so in order to get all the accounts that we have already created using Truffle Develop into MetaMask, we can import with DEN. So for our Truffle Develop, the wallet seed is always same, and it's this which I'm copying it. So let me do this again. So I didn't copy it, and I'm creating a password now. Click OK, and now you can see we already have some ether into the account one. And if you want, we can create a new account as well. So it has 0.0005 ether, the first account. The first account is 0.62, but this is connected to main network. Should not be connecting to main network as you have seen previously. Our RPC URL is different. It's HTTP localhost 9545, and I want to connect to this private blockchain RPC. So once it is done, I can go back and I can see that my first account has 99.232 ether. Even if you see the address, so it's 6273, and if you see my Truffle develop, it's 6273. The first account by default got added here. So now that we have we have done the setup of MetaMask, it's quite easy to talk to our network now. So these are all the same steps. So we'll be using a light server, which will be serving our web application. That's very easy. In order to run it, we just need to call npm run dev from the same folder. So let me open the PowerShell and go back to my root directory. I've created all the required files here, and I'll run the command npm run dev. So it uses light server and serves our index.js index.html file. So I've just ran it. It's using light server now, and it will open up the application in Internet Explorer. So Internet Explorer has no MetaMask extension. So I'll be copying the URL and I'll be opening it in Chrome. If you see, these are images and the functionality, everything is the UI. From the UI perspective, everything has come from the Truffle box. So let's open this in Chrome. So in Chrome, we have already connected to our Truffle develop blockchain. So now that we have everything, we can start testing this. We have 16 pets, and as we have just started, no pet is adopted yet. So if I am interested, my account is this one and I have 99.232 Ether. And if I am interested in adopting, let's say, Scottish Terrier, I can click on adopt. So when I say adopt, this will, when I click on adopt, this will going to trigger the smart contract and assign this pet to me, the pet Gina to me, and I'm clicking on submit. So if everything is good, it should give me back it should give me back the success message here. Let me refresh it once and maybe try Collins. So I clicked on Collins and I'll click on submit. Didn't work. Let me try for Melissa. So this didn't work. So let me see if the transactions are going in. Yeah, looks like the transactions are going in. They're not committed. Mhm. Now let's see the demo of this. I have MetaMask and I have connected to 9545, which is a Truffle blockchain simulation network. And let's say I want to adopt Gina. We have 16 pets in this interface. We can adopt any of the pet. Let me select this. So this is my contract address and we're trying to submit it now. So we did submit the transaction. Let me see it again. Don't see the transaction here. Let me resend the transaction. Okay, this time it worked. It shows success, which means that I have successfully adopted Scottish Terrier. Now let me adopt French Bulldog. I think even this transaction is taking time. Maybe let me try again. Because it's successful. Okay. Somehow the transaction didn't go through. If you see here, you can see all the transactions. Let me adopt this. Submit. Success.